So this is going to be a six-part video in which I discuss what titration is. I'm going to walk through a titration practice problem in which we start with a weak acid and titrate with a strong base. Now it's important to know that when you do a titration, you do your calculation based on where you are in the titration process. There are some key calculations or key processes that you need to look for. The first calculation would be before you add any of your titrant. So if you start with a weak acid, you're just starting with that weak acid and no base has been added. This calculation is just going to be your basic rice table sort of problem. Once you start adding base, you you kind of are in this buffer region before you reach what is known as the equivalence point, you will use the Henderson-Hasselbalch equation to determine the pH. Once you get to the equivalence point, that's when you added enough base to completely consume your acid, at which point you're now looking at the conjugate base instead of the initial acid. So that is where you use your rice table, but it is the flipped version. Instead of looking at Ka, we're now looking at Kb. And so for starting with a weak acid and titrating with a base, you go from solving from pH directly to solving for pOH and converting to pH. After the equivalence point, now we're in the excess base range. At this stage, you have an excess amount of strong base, and so you just have to figure out how much excess base you have, and then do the standard negative log concentration in order to get either the pH or pOH. Again, when we start with a strong acid and you add a base, you are going to find the pOH at this stage and convert it to pH. Some things to note is when you're starting with a weak acid and titrating with a strong base, when you reach the equivalence point, it makes sense that the pH should be greater than 7. That is because, again, the base is stronger than the acid, and so when you have equal parts of both, you would expect the pH to be basic or greater than 7. Another part to note is when you reach halfway to the equivalence point. So if the equivalence point is at 25 milliliters, halfway would be 12.5. That value there is going to equal the pKa. The pH equals the pKa. Um, and so what we're going to do is work through these 5 different scenarios where we add no base, where we add um, base before the equivalence point, one of them being halfway, one being another point. We're going to look at the equivalence point and then beyond the equivalence point. So those are going to be parts 2 through 6.